Ever wondered what really happens inside an AI brain? In the next 20 minutes, we'll break down how AI models learn, make decisions, and even predict the future, all through simple animations you can actually understand. Before we go any deeper, we need to understand the one concept that everything in artificial intelligence is built upon: the AI model. An AI model is much more than a line of code or a program following instructions. It's a sophisticated structure of mathematical rules and algorithms designed to learn patterns from massive amounts of data and then use those patterns to make predictions, decisions, or even generate completely new content. Think of it as a digital brain, but one that's trained instead of born. Every time the model analyzes data, whether it's millions of images, conversations, numbers, or sounds, it adjusts itself, reshaping its internal structure to better understand the world. Over time, these adjustments form something like a memory, a map of what the system believes the world looks like. But here's the key. An AI model doesn't know anything like humans do. It identifies mathematical relationships that allow it to predict what usually comes next, recognize what belongs to which category, or generate answers that feel remarkably human. Neural networks are the core architecture behind modern AI, and they take inspiration directly from the human brain. Instead of biological neurons, we use mathematical ones, small units that receive information, transform it, and pass it forward. These units are arranged in layers: input layers that absorb raw information, hidden layers that detect deeper patterns, and output layers that produce a prediction or a decision. Each connection between neurons has a weight, like a volume knob that determines how strongly one signal influences another. As the network processes data, these weights shift constantly, helping the AI discover hidden patterns humans would never notice. This layered structure is what allows AI to understand images, classify objects, transcribe speech, translate languages, and interpret the meaning behind sentences at speeds a human brain could never match. But despite its incredible speed, the neural network still faces a critical question. How does it know whether the answer it gave was correct, or completely off target? To learn anything at all, AI needs feedback, and the training process is where the magic truly happens. Training an AI model is like guiding a student who starts with absolutely no understanding of the world. At first, the model guesses wildly, incorrectly, even hilariously. But every guess triggers a correction. The system compares its prediction to the correct answer, calculates how wrong it was, and then adjusts the weights inside the network. This cycle repeats millions, sometimes billions of times. Each repetition reduces error, strengthens the model's internal intuition, and gives it a sharper understanding of the patterns hidden within the data. This is why AI can identify a cat even if it's upside down, in low light, or half hidden behind a sofa. It wasn't shown a single perfect image of a cat, it was shown thousands of imperfect ones. And through trial, error, and repeated refinement, it learned what features truly matter. But training isn't flawless. The AI can absorb human biases hidden in the data. It can overfit, memorizing instead of generalizing. And sometimes, it learns something surprising, something even its creators didn't predict. And as AI evolves, we discover not one type of intelligence, but many. The world of AI isn't dominated by a single model. Instead, it's an ecosystem of specialized intelligences, each designed for a different challenge. Supervised learning models learn from labeled examples. Images tagged as dog, car, or tree. This teaches them to classify and detect patterns with extraordinary accuracy. Unsupervised learning models discover patterns without labels. They cluster similar items together, reveal hidden structures, and uncover relationships no human could manually map. Reinforcement learning models are entirely different, they learn through experience, trial, and reward. This type of AI plays video games, flies drones, controls robots, and learns strategies simply by trying, failing, and trying again. And then come the creative models, the generative AIs that write stories, compose music, design images, and even build new worlds. Each type of model is powerful, but none can do everything. They form a toolkit, different digital brains crafted for different purposes. But which of these models is working behind the apps, tools, and systems you use every day? When facing a decision, AI doesn't hesitate, question, or reflect like we do. Instead, it calculates probabilities, thousands of them, in a fraction of a second. Every option is weighed based on patterns learned during training. The model evaluates which outcome is statistically most likely to succeed, and chooses that path. This is why AI can outperform human champions in strategy games, detect diseases earlier than doctors, and predict market behavior with astonishing accuracy. But this approach also has limits. If the AI encounters something it has never seen before, something entirely outside its patterns, its confidence collapses. It begins guessing again, much like a student facing a question they were never prepared for. So what happens as AI becomes more powerful, more capable, and more unpredictable? The answer lies in understanding its potential and its boundaries. AI models aren't magical beings. They are systems built from mathematics, data, and billions of tiny adjustments working together. And yet, when you see what they can do, generate art, write stories, power self-driving cars, diagnose illnesses, it feels like witnessing something beyond technology. Understanding how these models think is the key to using them wisely. Because the future won't belong to the people who fear AI, but to the people who understand it, shape it, and harness its power. So let me ask you, which part of AI fascinates you the most, creativity, decision-making, or the science behind its digital brain? Tell me in the comments, and don't forget to subscribe for more visually explained AI content.